Where? Yeah. So yeah, no. See, the point is you will have to. Yeah. Yeah. No, that's fine. See, the point is not to make you familiar with everything under the sun on Python, but to just give you the idea on how you can search for concepts that you don't know, right? So if you will have to use Google in a lot of your case studies, yeah. Yeah, so that will be there. Now, I understand that all of you have got this 10 question sheet. Now, one function which you will might, I mean, which you might want to use here is how you can take a user input, right? So, for example, um, here, right? So, suppose you have to write a program to calculate the factorial, right? To calculate the factorial, um, you need to input the value from the user, right? So there are two options. Either you can use raw input if you are using Python 2.7, or if you are using Python 3, you can use input, right? The format is input, then within bracket the message that you want to show to the user, and then I mean, if I run this, it will give me a prompt like this, right? So whatever value I enter here will be stored in X. Okay, so this is how you can take input from the user. Okay, so this is one function which I wanted to discuss because raw input will not work for Python 3. In Python 3, you'll have to use input. Make sense? Okay. Now, the next thing. So, any questions on any of this? So here is okay. So write a program that accepts a sequence of white space separated words as inputs and prints the words after removing all duplicate words and sorting them alphanumerically. Okay. Yeah. So what you need to do here is when you take the input of white space separated word, convert this to a list of words, not list of alphabets, list of words. So once you convert this to a list of words, then if you sort it, rest of the things will. Yeah. Is anything else? Sorry, but just let me go through it. But which one? First question or second question? Yeah, first one. So what did you do? Yeah. Yeah, so that will also work. Yeah. See, the requirement is you just have to output all numbers between 2000 and 3200 that are divisible by 7 but are not divisible by 5. Whatever way you feel is appropriate, you can do it. you should get the output which will have numbers that are divisible by 7 but not divisible by 5. What will not work? So is this one? This one? Uh-huh.
I think N may not work. So you have to write down the N. I think NumPy you should.
Yeah, you can use A and D. Okay. That ampersand will also work if you enclose these into brackets.
Yeah.
Then it will work. Yeah. Take it, make it a list and print. So it will come in a single line. Or start with a blank list, what she did, right? Started with a blank list and then kept on appending the numbers. Which one? This one? Yeah, I mean, ignore the solution for now, right? This is just for a demonstration. Yeah. Yeah. It will work, right? This works.
No, but you need to do more. Something you need to
Two methods.
So what is the difference between get string and print string?
There is no, I mean, see, it says that you need to create two methods. Name of the first method is getString. Name of the second method is printString. There is no meaning.
Okay,
These are just name of the methods. Yeah, I mean, it's already given, right? So this will work. Yeah, this will work, right? So for now, you can ignore the solution if you want to come up with something else. Yeah, this is one of the solutions. Okay, actually what happened was in the last batch, there was a question on this. So I guess we solved it. Then I forgot to delete it. Okay. Yes, any other question? Okay, so let me delete this. Cool. So this is the exercise that you have to do now in terms of timeline, right? So you have got this exercise on 23rd, which means it has already been a week. So what you should ideally do is finish this by the next week, because next week you are going to get exercises on pandas, and those will be much bigger than this, right? So try to finish this by then. Yes. Next Saturday or Sunday, depending upon the pace, we will give you the exercise. Okay. Now, coming back to the pandas analysis that we were doing, any question on what we have done so far?
so I had a question.
Yeah.
In the NumPy, what is the difference between ND array and the normal array statement?
Okay. So in NumPy, when I say, so let's start with ND array, right? So
Yes,
when
sir.
I say ND NP, okay, so you are talking about np.array or
ND dot array, sir.
nd.array?
ND.
So where did we do ND array? Did we do ND array? Oh, okay, got it. Oh, np.nd array, right? Okay, I thought ND array is some other function. What is the output? I'm also using Python 3.
Maybe I have done some mistakes. So let's see now.
Okay, so the difference between np.nd array and np.array is np.nd array will fill the array with random numbers, whereas np.array takes from you what are the numbers that should be used to fill this array. That's the only difference.
Okay, sir.
Yeah, so you see when I run np.nd array, there is no input in terms of the numbers that need to be used, right? I just input the dimension. But when I use np.array, I give it the values that have to be used to fill this array. Make sense?
Sir. Yes, sir.
Okay. Now, any other questions?
So in the pandas, what is the difference between lock and ilock?
So ilock basically takes the row number and the column number. Lock takes the row name and the column name. Now in our case, the row number and the row name are both the same. So that's why they might seem to be very similar, but they are different. ilock takes row number and column number. Lock takes row name and column name. Yeah. Anything else? You were saying something. You have faced an error? Okay, just help me replicate the same error. So we'll start from there. Okay. So what did you try to do? Monthly income. Okay. Cast underscore data bracket y income greater than what? Yeah. So if I run this, oh, I have not used the small. You are getting this error. Yeah. Okay. What you should do is truth value of a
2000.
no, it's not a series, it's a data frame.
I think 12,000 should go at the last. Cost data monthly income is smaller than 12,000.
So let's try these separately. Okay. This works. Right, it's giving error.
So why we are going to put 12,000 before cost data monthly income?
Or what you can do is, sorry, just a second.
Sure.
But why is the AND condition not working? Just give me a second. AND condition should work.
If we put a whole thing in the bracket, then it will work, I think, because it is making the two values, so it is making series. We should put in whole one bracket.
Okay. So here you have to use ampersand. The reason being, let me understand why. So let me take the type of this. No. Yeah. The reason you can't write this is the output that is coming is a panda series. And in panda series, the AND operator is this. Yes, it's a series of Boolean values. So you see, I checked the type, right? This is the series of Boolean, right? So for this, it is coming a series. And in series, the condition for AND, I mean the syntax for AND is ampersand. Okay, so let's do OR. Yeah. Used to use is okay. So you want to start with greater than, okay. Easy way to do this is Yeah. Okay. Anything else? Okay. Yes. Any other question? Now you know how to get the data, right? So if you want to get the data, you have to again write cust underscore data. So yes, this will give you the data. There is see for a pandas data frame there is no difference. In pandas series the ampersand at the and operator does not exist. The equivalent is ampersand. Similarly, or does not exist. The equivalent is piping. First question. It was printing. Yeah. Yeah. The reason being. Uh-huh. These are the values, right, which are divisible by 7 as well as 5. Okay. Yes. Anything else? Again, so where here it will work with A and D as well. That's what you're saying, right? This, right? The reason this will work is what is the type of X? What is the type of X? So in integer and exist. But when we are comparing, we're comparing two pandas series. So I would say the safe bet, if you don't want to remember this, is to always use ampersand, and whenever you have conditions, enclose them into brackets. Okay. Yes. Anything else? Anything else? Okay. Now, so far what we have covered is how to sort data in ascending order using NP. So Gaurav, what do you mean by this? So why would you want to use NP to sort a particular data? Yeah, so what data structure do you want to sort? Okay, so NumPy array, right? So this is how you can sort based on an axis. We discussed, right? Axis equal to 0 will sort by through rows, axis equal to 1 will sort through columns. Yeah, so what is your question, Gaurav? I mean, it will be better if you can speak up. Okay, now moving on to pandas, right? So the things that we have covered so far.
Excuse me, sir.
Yeah.
Sir, Ashish, this side, actually, when I am going to put n% there in the first question, it is not going to work. A and D is working.
Sorry, which one?
In first one, when I am going to put n%, it is not going to work. A and D is working.
I demonstrated, right? The ampersand is working. I tried out.
N% is not working.
I tried out with ampersand first, right?
Uh,
It is working. So see, at the end of the day, you were able
mine
to
is
do it, right?
right.
Then that's fine.
Okay.
Okay. Now, so what we have covered in pandas so far are importing the data. Then we talked about
Hmm.
indexing based on rows and columns. Right? I think this is about it, right? And then we also talked about things like info, D type, and F type. That's about it, right? Okay. So the next thing that we are going to talk about is how you can create variables and delete variables, because when you are analyzing a particular data, the ability to create and delete variables is very important. Why? Because the deletion is very evident. It is important because you might have a lot of data which is redundant, so you might want to delete certain variables or more than one variable. But creation is also important because you might want to combine one or two variables to come up with a new variable of your own. Okay, so for example, let's talk about the creation of a particular variable first. Let's say I want to create a variable which gives me the number of times a person has gone past 30 DPD. We explained what is DPD, right? So 30 DPD basically means 30 to 60 and then 60 and above, right? So what I just need to do is get a sum of these two variables or these three variables, right? So the way by which you can create new variables in Python is by directly writing the name of this new variable. Say what I'll do is I'll write cust underscore data and whatever is the name of the new variable. And then what I will write is, let's say I want to create this new variable which has monthly income in thousands, right? What I'll simply do is I'll divide the income by 1000. If I run this, what will happen is a new variable will be created which has monthly income in thousands. Similarly, if you want to combine one or two variables, you can use a calculation like this. For example, this particular line will create a variable which is sum of three existing variables. Make sense? So here if you see, this new variable has come, which was not there. Right? So the format to create a new variable is data frame in bracket the name of the new variable and I assigned, right? New variable, and then you write whatever is the calculation. Now the calculation might be, might include one or more than one existing variables. That depends upon what you are trying to do. Yeah, sorry. Yeah, I created this new variable. No? Forget about this new variable. I just created this one. Yeah? Now, this is the most usual way of creating variables, but there is also another way by which you can create a variable, which is by using a method called assign. Now, what assign method will do is, and this is the exact format, the assign method at a time can create multiple variables. Now, if by using this approach in a single line, you can create only one variable. Yeah, because it is data frame in bracket variable name and then the calculation, right? But if you are using assign, what you can do is you can give the creation of multiple variables separated by comma. Say for example, apart from this 30 plus, I also want to create another variable called monthly savings, which is 15% of the income. So what I want to do is I want to create another variable, which I assume that people usually save around 15% of their income. So I simply multiply the income by 0.15 and create a new variable called monthly savings. If I would have had to do it this way, it would require 2 lines because it has 2 variables that I need to create. But if I use assign, I can directly create these 2 variables or more than 2 if required within a single assign command. The only difference is you have to separate them by comma. So the format of assign is DataFrame dot assign, then within bracket name of the new variable 1, then the calculation, then after comma, if you want to create another variable, new variable 2 followed by the calculation 2, right? And so on. You can create as many variables as you want. But there is a difference. The difference is what assign will do is assign will not temper or change the original data frame. It will create a new data frame with all the pre-existing variables and the new variables that you have created. So if I run this data, so if I, for example, run this line and then I look at cust data, right? Cust data will not have this monthly savings. This 30 plus DPD though I have already created here, right? So that will be there, but this monthly savings data will not be there in this data frame. You see, it stops at 30 plus DPD, which I had already created in the previous step. Now, so if you are using a assign, you will have to store this into a new variable. That's why you see I have written cust underscore data 1, which is the new data frame that has all the old variables plus these 2 new variables that I have created. Now, why would you want to use this? Because it basically will occupy double the data space. It preserves the old one as well as creates a new one, right? This you will use if you want to break up your steps. Say, for example, during analysis, often you are not sure of what should be the next step, right? So what you might want to do is you might want to save a particular version of a data set before proceeding with the analysis, so that if you want to come back, you have the original data set there. You get my point? So it's like saving a version of Excel. If you're working with Excel, often what people do is they'll save at different times. So this is often used if you want to have a copy of the data frame as a backup to fall back if required, right? That's the only utilization. Otherwise, every time you will probably use this. This is what I feel most comfortable in. If you want to use assign, it's good as well. No,
Sir, can
nothing that you do on this data frame affects the CSV until you tell Python to save. There is a way by which you can write it to a CSV. Until and unless you explicitly tell Python to write something in CSV, your CSV file remains unchanged. Whatever you are doing is only happening in the runtime memory. Yes. What was the question?
Sir, what is the explanation for the number underscore of underscore 30 underscore plus underscore DPD means?
So number of 30 plus DPD is the name of the new variable, and I am creating this variable by adding number of 30 to 59 DPD, 60 to 89 DPD, and number of 90 DPD plus. So this new variable is basically sum of 3 old variables.
Okay.
So you see these old variables are there, right? Number of 30 to 59 DPD is there. Number of 60 to 89 is there. Number of 90 DPD is there. I'm simply creating this new variable by adding the 3 old variables.
Okay, sir.
Okay. Yes. Are you clear on this? Okay. So this is how you can create a variable, right? Again, if you want to remember one out of these two, I feel method 1 is easier to remember because it's just data frame within square bracket name of the variable. You don't need to remember this assign and all of that. And if you still want to create a backup, what you can always do is you can write cust data underscore backup equal to cust data. That will save the cust data in a backup folder or in a backup data frame. So if you really want to create a backup, what you can do is you can write something like this, right? So backup underscore data frame is equal to data frame. This will save it into a backup data frame. Make sense? Yeah. So whatever was this in this data frame, we stored in backup underscore. Okay. So if you want to create new variables and want to have a data frame with only new variables, you can, I mean, we'll talk about dropping those variables. You can drop the rest, right? But there is no way by which you can create a data frame which has only the new variables. I mean, you can create, there is a way. I mean, the easy way is create three variables as pandas series and then combine those series to get a data frame. We'll talk about how you can do that later on, right? But as of now, there is no way. Okay, now, so any questions on the creation of the variable?
Sir, if we using the assign method, then we have to use a different data frame, new data
If you want to
frame.
store it, yeah. Because assign does not change the old data frame, right? So you'll have to store it in a new data frame.
Okay.
Yes. Yes. You were not there last week, right? Okay. Okay, so if you're not there in a particular week, please go through the recordings. But yeah, I will repeat it once on the final time. A data frame is like an Excel sheet. It will have a number of variables and number of records. And variables, a single variable will be of a particular type, either it's an integer or a float or an object. But a data frame can have multiple variables of multiple types, just like an Excel sheet. Yeah. So a data frame is basically a set of different variables on multiple observations. So it will have multiple columns and multiple rows. You understand when I say variable and observation, all of you understand that, right? Variable means a column, observation means a row. Okay. I mean, the easier way to remember is, say I observe any one of you, right? I observe you. What do I observe? I observe skin color, hair color, gender, probably height, etc. Right? All of these are pertaining to one single person, right? If I have to record it, I'll record it in a single line, whereas the columns will be the attributes. What is the height, what is the skin color, and so on. So variables become column, observations become the row. Yeah, okay. Any other question on this creation of new variables? No questions? Okay. Now, after creation of the variables, the next concept that we are going to look at is how you can drop variables. So when you want to drop a particular variable, what you can do is you can use this method called dot drop, right? Say for example, I want to drop this variable monthly savings 1. So let me first create this variable monthly savings 1, right? Now this data frame has a variable called monthly savings 1. Monthly savings 1, right? Let's say I want to drop this variable. What I can do is I can write data frame dot drop. Within that, I can write the name of the variable, or I can pass a list of variable names if you want to drop multiple variables. And then I will write a axis option. Remember the axis option in NumPy? Okay. Now using that axis option, tell me if I want to drop a particular column, what axis should I choose? Axis 1. Okay. So if I run this, you will see that, okay, cast data 1. So if I run this, you will see that monthly savings 1 is still there. What should I do? Okay. Now, in Python data frame, there is a concept called in place. Now, what do I mean by in place? Let's have a look. If I would have simply run this command, right? I have commented everything else. If I just run this command on its own generates a view, right? And if you look at the view will not have this column. Do you understand? See, initially I have created this column monthly income, monthly savings 1. So you see the column, this new column is created, monthly savings 1, right? Now I am writing monthly savings 1 drop axis equal to 1, which is perfectly okay. So it should drop a column, right? Now if I run this in fact gives me a view after dropping the column. The column does not exist, right? All of you agree, right? Column does not exist. But if I print the data frame, the column is there. Yeah. So what happens is, if you just write this, what Python does is Python produces a view. It is not replacing or changing the data frame. It just gives you a view of what it would look like if you had dropped this variable. The original data frame remains intact. Now what you can choose to do is you can choose to save this view in a new data frame. That you can do. Yeah. So you can choose to save this into a new data frame. But let's say you want to not save this in a new data frame, but you want to change the original data frame. Then what you have to do is you have to write here in place is equal to true. In place equal to true basically tells Python that it will have to change the original data frame. Okay. Now if I run this, no view is generated. You see, there is no view. And if I look at the original data frame now, this will not have the column. Make sense? So when you are dropping these a particular column, you have the option to either only see the view and maybe store that view, or you can change the original data set. Just like creation of the variable. In the creation also, you had the option of creating the variable in the original or using assign to create it in a new data frame. Similarly, here also, by using in place option, in place by default takes false, which will only give you the view. If that will, you will have to store it in a new data frame. But if you use in place equal to true, it changes the old data frame. Make sense?
So one question is there.
One second, I'll come to the online question here. Let's say you drop a column and you write in place equal to true. Yes. Yes, yes. Ha. No. No. The reason in place option is given to you is to make sure that you are sure of dropping before you drop it, right? So when you say is equal to true, it is gone for good. You will not be able to retrieve that column. I mean, always you can go back to the place where you have created the column to, get it, but anything anywhere after this, you will not be able to get the column. Yeah.
And if we write false in place of true?
In place equal to false is not good at not writing. You remember in function we talked about default argument?
Yes, yes.
So in place, this is a parameter, this is a user input.
Okay.
The
Okay.
default value of this user input is false. If you do not say anything, it will take false.
So what will happen if we take false? Then the column will not be dropped, and
Yes, then the column will not be dropped, but Python will give you a view which you can
yeah.
store in a new data frame.
Okay, okay,
Yeah, the original remains unchanged.
sure.
So it is like deleting a table from a database and not committing it.
Sir, I
Right.
have no idea about
Okay.
databases. Okay. But yeah, I mean, I worked on database, but yeah, it's like, not committing the change.
Yes.
Okay. Okay, it makes sense how you can drop variables and create variables. Okay. Now, this drop command can also be used to drop rows. Okay. Now, if axis equal to 1 drops columns, what will drop rows? Axis equal to 0.
So is
Yeah.
equal to 0.
So
Axis is equal to 0.
right. So the generic format of drop is cast underscore data, which is name of the data frame. This is the generic format, right? Cast data, then drop. Now within drop, when I was dropping the column, what did I give? The name of the column. When I am dropping the row, I should give the name of the row. In our case, name of the row is same as the row number. So what I can do is I can pass a list of row numbers, right? And then I can write access equal to 0. And let's say I don't want to save it. So I don't give anything in place of in place, right? So if I run this, what will happen is you see the observation starts from number 2. So 0 and 1 has been dropped. But has it changed the original data frame? No. The original data frame is still there. It will only be changed if I write in place equal to true. Make sense? Okay.
Sir, two
Sorry?
things are there. First is like if we are going to put,
Conditional formatting.
sir.
No, see, a conditional formatting is only possible if you are printing it. I am not printing the data. This is just Jupyter Notebook's way of telling you that this is what the data looks like. This is not a print. Yeah? But yes, conditional formatting is possible if you are actually printing it. If you're using a print command to print a particular line, you can choose to give formats. Yeah. Okay. Yes. What was the question from online?
Sir, two things are there. So if we are going to put column name, so by default axis should take 1, right?
No, there is
So
no by default, right? So Python will only do what you are asking him to do. I can even try dropping a monthly savings one by saving axis equal to 0. It will give me an error. So there is no by default. Whatever you say, Python will do that. If you say monthly savings one and axis equal to 0, Python will look for a row whose name is monthly savings one. It will not find it. If you write axis equal to 0 and pass row numbers, Python will look for these. I mean, in the row numbers, if it finds it, it will drop. Otherwise, it will give you error. Right? So the generic format is name of the row or column and then the corresponding axis that you want to look for those names.
okay, and could you please repeat like in place is equal to true? What exactly? Could you please repeat that?
In place equal to true, if it is mentioned, it will change the original data frame. If it is not mentioned, it will not change the original data frame, but only produce a view which you can store in a new data frame.
Okay, okay.
Make sense? Okay. Now, so Gaurav Mishra, is it possible for you to please speak up? Otherwise, it gets difficult for me to track these chats. Okay. Can I create new variables and save them in new data sets where, okay, it's done. Okay. Can we create new variables with no values? Okay, so what you can do is you can write either you can write this or you can write nothing, or you can write null, whatever, right? Whatever value, I mean, if you want to create a blank column, this is what are the options, right? But why would you create a blank column? And any other question? Yeah, if you want to delete 100 rows, what will you write? Yeah, so you will write a range. So if you want to delete 100 columns or 100 rows, what you can do is you can write a range, say 1 comma, I mean 0 is no longer there, right? We dropped it. So it will start from say 2 and go till 97.
But we have not did in place, so it should be there.
Oh yeah, it should be there, right? This has dropped. Okay. See, line number starts from 98. Okay. Any other questions on drop and creation? Okay. Now, just to recap, if you want to delete variables or rows, the generic format is DataFrame dot drop. Then in a list, pass index. Index is the generic term which can be used for both row names or column names, right? Pass this list of indexes. Choose axis equal to 0 or 1 and choose in place equal to true or false. Make sense? Okay. So this is how you can create and drop variables. Now, the next concept that we are going to talk about is known as binning. So what do we mean by binning? And most important is, why would you want to bin, right? Binning basically means categorizing our continuous variable. All of you understand what is a continuous and a categorical variable? No? Okay. So, see, if you don't understand, please be much more vocal. So, a continuous variable, right? A continuous variable is any variable that can theoretically take infinite values. Example, age. Age can theoretically take infinite values, right? It can start from 0 and go to, say, infinity, and it can take any values in between. A person can be of age 13.00001 years, right? This is an example of continuous variable. The thumb rule is, if any variable can take a decimal point as a value, then it is continuous. That is the thumb rule, right? Theoretically, it means any variable which can take infinite amount of values in a range. Now, what is a categorical variable? So if the continuous can take infinite value, categorical is a variable which can only take finite values, right? So it can take finite values. Example, gender. Gender can only be either male or female or a third gender, right? It is finite. You do not have infinite values of gender. Second, hair color, skin color, right? Your city of residence, right? All of these are categorical variables. Make sense? Okay. Now, binning is basically the method to convert continuous variables into categorical. That is known as binning. Why would you want to do it? Let's understand that first. The reason you want to convert continuous variables into categorical is to help in interpretation, right? For example, let's say you have a variable called income. Now, income is a continuous or categorical? Continuous. Theoretically, it can take any value between 0 and infinity, right? Now, if you are analyzing income, looking at the raw income value might be very difficult, because you see, each and every person will have different values of income. Right now, how do you interpret that? What people often do is they'll define bins. So they'll say any income between 0 and 10,000 is known as low income. Any income between 10,000 and 50,000 is known as medium income. Any income above 50,000 is known as high income. Now, this new variable that you have created is continuous or categorical? Categorical, because it can take only 3 values. Now, this variable makes much more sense than a raw number. Now, if given a particular person, you will say this person has low income, this person has high income, this person has medium income. Make sense? Similarly, you can do with age. Age is also another variable which is binned. Why? Because looking at an age number of, say, 17 years, 6 months, 23 days does not make any sense. What you would want to ideally do is group them into brackets like, young, infant, middle-aged, old, and so on. That makes much more sense, right? So binning is usually done to to make a variable interpretable. Make sense? All of you agree? Yes, sir. Oh, we'll come to that, right? Now let's talk about the concept. Right exclusive, left exclusive, we'll come to that. Okay. Makes sense? This makes sense, right? Okay. Now, so binning makes a variable interpretable. Now, what is the drawback? The drawback of using binning is you lose information. For example, let's say I say that everybody between the age of 0 to age of 10 is infant. But is a person of age 0 same as a person of age 10? No, no, right? But in the new variable that I've created, they all are the same. So I lose information, right? So basically in analytics, you by doing something, you lose something, you gain something, right? So by doing binning, I lose information, I gain interpretability, right? Now, depending upon what is more important, you might want to choose to do binning or not do binning. Depends upon what is important, whether accuracy is important or interpretation is important, right? You will see this trade-off everywhere when we talk about analytics, right? In analytics, one of the major concerns is whether accuracy is more important than interpretation, right? And depending upon the business case, people choose one or the other. So if your business is more interested in the interpretation, you will bin everything. If they're more interested in the accuracy, in the decimal point accuracy, then you will not do binning. Make sense? Okay. Now, binning can be done in 3 ways. The first way is what we discussed. You already know the bins. You know that I want to bin age between 0 and 10 as young, 10 to 20 as middle age, whatever 20 above as old or whatever, right? You know the ranges that you want to use, right? That is the first method, which is manual binning. Manual binning is where you know your bins, you know what kind of bins have to be defined. The second kind of binning is known as equidistant binning. And the third kind is known as equidense binning. Okay, 3 ways: manual binning, equidistant binning, and equidense binning. Okay, now all of you understand manual binning? Manual binning, there is nothing to explain. I mean, you either know the brackets, then you manually use conditional if else statement to create those variables. You understand how you can create manual binning? Yeah, so for example, let's say I want to bin this monthly income into high, low, and medium bins, right? What will I write here?
Cost data 1.
What will I write here? You will have to apply a lambda function basically, right? You have to
Yes.
create a new variable and apply a lambda function. We'll come to that, right? But you understand, right? You know the bins and you will have to create those bins. The second option is equidistant binning. So what is equidistant binning? In equidistant binning, the first step that you do is to calculate the minimum value and the maximum value, right? You calculate the minimum and the maximum value of this continuous variable. It's a continuous variable, so you'll have a minimum and a maximum. Now, then you decide how many bins you want. Yes. So first you decide, get the minimum, maximum, then you decide how many bins you want. The third thing that you do is divide the range into as many parts as bins. Okay. So for example, if I do it in Excel, let's say I have data on this variable age and I do not know what the bins should be, right? And I decided I will use equidistant. First thing that I do is I calculate the minimum age. Minimum is, let's say, 0. Then I calculate the maximum age. Maximum age is, let's say, is 70. Now I can get how many bins I want. Let's say the number of bins is 10. Equidistant means all of those bins will have equal ranges, like linspace, right? So what will be the range? First range will start at 0 and then stop at 7, okay? Then 7 to 14, 14 to 21, and so on, right? So this will give you 10 bins. Make sense? This is equidistant binning. Yeah. Why is it called equidistant? Because the boundaries are equally spaced from each other. If you take a range here, it will be 7, here also 7, everywhere the range of the bins will be equal. That's why it's called equidistant. Clear? Now, the next method is equidense. Now, before we go into equidense, let's look at what is the problem with equidistant binning. Let's say my range was from 0 to 70, right? But there was only one person with age 0 and everyone else was between age 63 to 70. Can happen? Yeah. So what will happen is there is one person here and let's say there are the rest of the people, right? If I had 100 people, this will have 99 people. All the other ranges will have 0 number of people, right? So the problem with equidistant binning is it does not look at the distribution of the data that you have. It blindly builds the groups. So there is no surety that, let alone less number of observations, it might happen that you end up with a group with 0 observations, right? So that is the inefficiency of using equidistant binning. Now, what is the advantage? The advantage is this is easier to interpret because you see everything is equally spaced, right? So it's easier to interpret. So the drawback is you might end up with a very skewed distribution. The advantage is easy interpretation. Let's understand equidense now. Equidense, what it will do is it will first start with calculation of number of observations. It will first look at how many observations you have. Then it will basically calculate, or then it will basically decide how many bins you want. Right? Number of observations, how many bins you want. Equidistant or equidense basically means each bin should be equal dense. Equal dense means they have equal number of observations in them. Okay. So if I want to distribute each of those observations equally across certain number of bins, how many observation will be there in each bin? Number of observation divided by number of groups. Yeah. Okay. Now, once you have decided the bins, then what it does is it will sort the data based on the variable that you are trying to bin. It will sort the data on the basis of the variable that you are trying to bin. Then it will create the bins. Make sense? Okay. Now let's do it in Excel. Let's say you have this same data of age, right? And I will fill it with certain random numbers. Oh, sorry, yeah. So this is age, and I have 20 observations of age. Basically, I've gone to 20 people and noted down their age, right? Now, if there are 20 observations, and let's say I want to build 10 bins, how many observations will be there in each bin? 2 observations. Okay. Now, so I know the number of observations, I know the number of bins. What is the third step? Sort the data, right? So I will sort the data with respect to age. You can choose to either do smallest to largest or largest to smallest. Equally okay. Usually people do smallest to largest, ascending, right? No, I sorted the age smallest to largest. Then what I will do is I will create this variable bin, and I will take the first 2 observations and assign them to bin 1. Second 2 observations I will assign to bin 2, and so on. No, not randomly, right? There are 19 observations. Okay, so I'll make it 20 to make the calculation easy. Huh? It's not randomly, right? So what I did was if there are 20 observations, I want to create 10 bins, and I want to create bins such that in each bin there are equal number of observations. So how many observations should be in a bin? 2, right? Now, how do I allocate these observations? What I do is I sort them by the value. Then I say the lowest value gets bin 1, the highest value gets bin 10, right? And then I distribute two observations in each bin. Make sense? This is known as equidense binning. Now, you might ask, what if there were 21 observations and I want to create 10 bins, right? 21 is not divisible by 10. What will happen is whatever adjustment is required will happen either in the last bin or in the first bin, depending upon what software you're using. So either the last bin will be heavier or lighter, or similarly for the first bin. Some softwares adjust the last bin, some software adjust the first bin. But that doesn't matter, right? In analytics, you are looking at large number of observations. 1 or 2 observations here and there doesn't make any difference. Make sense? Yeah. Yes. Any questions on equidense binning?
So can you repeat the last one?
The reason we sorted is because when we created equidistant binning, we knew that the first bin was lower than the last bin. We also wanted to make some sort of order in our bins. So we sorted them so that here also the last bin is greater than the first bin. Because if you allocate bins randomly, you can do that, but then the bins become equally uninterpretable.
Can you repeat the binning part after?
One second. I'm coming to you. Yeah. 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 You'll have to say I have one observation like 1, which is added. I'll have to figure out which bin it goes into. Yeah. No. My point was here I had 20 observations. So I could say that each bin will have 2 observations. But if I had 21 observation, 21 is not divisible by 10. So what will happen to that extra observation? So it will be added to the last bin. After sorting, it will be added in the last bin. Yeah. You'll have to recalculate the bins. So in equidense binning, whenever any new observation comes in, you will have to recalculate the bins again. Yeah. Yeah. So, but that is there in every case, right? Say for example, this is a equidistant binning you have created, right? The maximum was 70. Now a new guy comes with the age of 80. What will happen? You'll have to recalculate this, right? So any kind of binning. Similarly, let's say you did manual binning. In your data, you had only age from say 0 to 15, right? You manually binned it saying that 0 to 5 is young, 5 to 10 is like in middle age, not middle age, but young, not so young. 10 to 15 is like teens, right? Then a new person comes in with the age of 20. You'll have to again redefine the bins, right? Bins are only fixed until the data is changed. Bins are only defined with respect to the data that you have. If that changes, bins will have to be redefined. Make sense? Because the whole interpretation changed, right? Okay. Yes. What? No. You calculate this to help you make a variable or help you interpret a variable better. But yeah, I mean, one byproduct of this is, we'll talk about this. We'll come back to this, right? There is another concept called outliers, which get tackled in this way, but we'll come to this. Yeah. Equidistant. Yes, yes.
It's not the actual one, right? It's not giving you the actual figure. Because for 7 that is, let's say 6 point something is, it might be there is possibility that 2 number will not there. 2 bin weeks should not be there. But in equidence, we provided that too. I mean, I'm not able to get it.
Sorry, I did not get your question. You can speak in Hindi, any language that you are comfortable with. Equidistant will give me a range, right? Right. Now, purpose will be fulfilled in this way. Now, my bins are like this. So my first bin starts from 0.3 and goes till 2.3. Second bin starts from 2.3 and goes till 6.7, right? And so on. This become my bin now, right? I have just created the bins, but you'll have to calculate the ranges now. Yeah. I have artificially created data. I'll come to why this is important. I'll come to that. Yes, there was a question from online. Sorry to come back to you later. Yeah.
Oh, that's fine. You can continue.
Okay. Cool. So all of you understand the binning, right? Now, what is the advantage of equidence binning? The advantage is your population gets equally distributed among each category, right? That's the advantage. Disadvantage is this will become very difficult to interpret. Now, what might happen is, so let's consider a case like this. So let's say you have data on age where one person is having age 0 and then the next person has the age 39, then everyone has something like 40, 41, 42, 43, 44, 45, 46, 47, 8, 49, 50, 51, 52, 53, 54, 55, 56, 57. Yeah. Just a second. Okay. So let's say if I have a bin like this, right? Now, what happens to the definition of my first bin? My first bin has an age range from 0 to 39. Second bin has a range from 40 to 41. Right? Third, so on. Right? Now, how do you compare a range with, how you compare a bin with a range of 39 to a bin with a range of 2? Right? It becomes very difficult to interpret.
However, as I could see, the first two observations are into bin 1. So
Yeah.
how are you categorizing them into two different bins when they're both bin 1?
No, I'm not calculating them into two different bins. I am saying the range of age in bin 1 is from 0 to 39. Similarly, range of age in bin 2 is from 40 to 41. It is
So,
very difficult to compare these two bins in the same platform.
however, we'll have just one bin from 0 to 41, right?
We'll have one bin from 0 to 39. Right? So these two observations are single bin, right?
Yeah, 0 to 41.
0 to 39. 0, 39.
Okay, 0 to 39. Okay.
Sir, so there is some problem occurring in online video. It's going to be reconnect every time. It's 10 times as of now. It's going to be reconnect. We can do something.
Mine is perfect. I've been connected.
Yeah, I guess it's your internet connection, right? If it's perfect for everyone else.
Maybe you need to log out
I guess
and
it's
log
yes.
in.
Yeah, because your voice is also breaking. You might want to check your internet connection. Okay, now all of you
Net
are,
is going good.
sorry?
I don't know. Well, net is going good, I guess. Well, that's fine.
Okay.
I'm not sure.
Try on the mobile. Use the Zoom application.
Okay, now so there is a question which says that is there any statistical method to find the bin so we can get minimum to 25% to mean? Okay. Okay. So what he's saying is there any statistical method to get a bin? This is the statistical method, right? The statistical method is equidistant binning. Now, equidistant binning, if you choose to have 10 bins, it is known as decile. There is a naming convention, right? If you choose to have 10 bins, it's known as decile or deciling. The process is known as deciling. If you choose to have 100 bins, it is known as percentile or percentiling. If you choose to have 4 brackets, it is known as quartile or quartiling. 4 bins, 4 brackets, 4 bins. Make sense? So these are the name. From now on, whenever I say decile, I mean equidistant binning with 10 bins. We have not come to the concept of outline, right?
And these are for equidistance binning.
Yes. So all of these are for equidistant binning. So if in equidence you want to have 4 categories, then quartile, 10 categories decile, 100 categories percentile.
Okay, equidence. Okay.
Makes sense? All of you get percentile scores in your competitive exam, right? So that's based on equidence binning. Basically, a score of 99 percentile means that 99% of the people who gave that exam have scored less than equal to you. Right? Say, for example, I have done deciling, right? So a 10th or a 9th decile basically means 90% of the observations are either scoring very similar to you or less than you. That's what this means. Okay. Okay, so you understand the concept of binning, right? And what are the advantages and disadvantages of each? Now we will come to manual binning a bit later. For now, let's get started with equidistant binning, right? Equidistant binning in Python is done using pandas.cut function, pd.cut. What pd.cut does is, if I write pd.cut and then within bracket, I give the variable which I need to bin. So I give, say, monthly income. Okay, so the format is pd.cut within bracket, give the name of the variable. This works one variable at a time. Okay, now then after comma, what you need to tell is you need to tell how many bins you want. This is equidistant. Let's say I want 10 bins. Then you can choose to give names to those bins, right? Say, I mean, for 10 it will be difficult to give names. Let's say I want 3, right? And then I say I want to name the first bin as low, second bin as medium, and the third bin as high. Okay, so if I run this, what happens is it will create, sorry, yeah, so it will create, so if you check the type here, it is basically creating a panda series with respective bin values for each observation. Now, for example, if I want to interpret this, right? If I want to interpret this, I will say that the first observation lies in the low bin. Second, third, fourth, fifth, etc. lie in the low bin. Sixth observation is a missing value. Wherever it is a missing value, it will not be put into any bin. It will be a bin on its own, which is NaN. Makes sense? Because missing value you don't know, right? Whether it's more than or less than or whatever, right? So it will not be part of any bin. It will be NaN. So it is calculating on its own. Sorry, I did not get it. Oh, if you want to look at the brackets, what range it has come up with, the best thing to do is not go in Excel, do not give a label, right? If you do not give a label, it will instead show you the brackets. The brackets start from some random number. This number that you see is a random starting point that Python takes. Now what Python will do is, see, Python can build a range which is left exclusive. Here it builds a range which is left exclusive. See, there is a first bracket here. First bracket means exclusive. Square bracket means inclusive. Okay, so it builds a range which is left exclusive. Now, in order to say if I have 100 observation, the minimum value is 0. And I want to build the first bin as left exclusive bin. I'll have to take a value less than 0 so that 0 gets included. You understand? I want to define a bin such that the least value in the bin is not included there. But I need to include 0. So I have to define a bin range which is less than 0. Yeah. So here, the first bin, what Python will do is, in the first bin, the left value will be taken as some random value which is lower than the minimum value. Yeah. So you see minus 3008.75 is a random value it has taken. This number does not exist in your data. This is Python's way of defining a left exclusive bin, right? Similarly, it would have defined other bins in equidistant way. Okay. Now, yes, bin width. Yeah. So bin width always will be this. The difference between the max and the min will always be the bin width. Yeah, it will affect the distribution. Yeah. Not a drawback as such. Okay, so let's look at the data. So then it will become clear. So it does maximum minus minimum, but then it has to build a left exclusive data, right? Left exclusive bin. So it has to choose a value lesser than the minimum so that the minimum also gets included. Yeah, so that's what we'll look at, right? Say for example, let's look at monthly income. Now, if you look at monthly income, its value, the minimum is 0 and the maximum is something 70,000, 7 lakhs 2,500, right? So if I want to divide this into 3 parts, let's say what happens. So 0 and 7 lakh 2,500, right? I want to divide. Sorry. I want to divide this into 3 parts. What should I do? I'll take first the range, minimum minus maximum. So range will be this minus this. I need to divide this by 3, right? So this comes around 2 lakh something, right? Okay. So what you see here is one. This is
More than 1 million. More than 1 million.
So what was the maximum there?
70 lakhs.
Oh, maximum was 70 lakhs, right? Okay.
702,000.
It's 7 lakh, right? Are we referring to the same data? We're referring to cost data. For example,
So could be the reason that it is taking to minus 38.
no. I mean, it can never go above the range, right? So that's the problem.
Okay.
Why is it going above the range?
Just see if you have just filter applied over there. Does it causing a problem? Can you see the filter in your sheet? Does that causing the problem?
Filtered out hash NA.
Okay.
Let's check the maximum value there. It will become clear. The maximum value is lower here. It's 30 lakh.
3 million, yeah. So that's fine. 3 million is the maximum value. And if it
We are
divides,
using some other data.
it's 1 million. So I think it's coming right. So 1 million each bin will be 1 million of it.
No, I understand, but let me verify the data. I am picking up some other data, I guess. Whatever, right? Let's not go into the data. So you understand the maximum value is 1 million, right? Okay, let's check the minimum value. Let's do it from here now instead of doing it in Excel. Okay. So we are doing this. Yeah. So the maximum value is 3 million something. And if I want to check the minimum value,
Must be 0.
minimum value is 0. Okay. Now, so if I have a range which is this, so I have a range which starts at 0 and gets to here 3,000,8750. Okay. So what will be there in a particular bin? Minus this divided by 3. So this will be the bin width. Okay. Now let's look at the bin boundaries in Python. See, it is round about the same, right? So what it does is, for the first bin, it takes a random number which is less than the minimum, right? So your bin definition gets very similar, right? You will get the same observations, but since it has to build a left exclusive bin, it has to choose a random point which is lower than minimum. Yeah, makes sense? Okay. So this is pd.cut, which builds equidistant bin. Now, in pd.cut, there is also option of building manual binning, right? What do you mean by manual binning? Let's say I want to build bins such that one bin calculates income or stores income between 0 to 10,000. Second bin will store from 10,000 to 20,000. Third bin will store from 20 to 30,000. Yeah. So then what I can do is I can write pd.cut, then the name of the variable. Then instead of giving the number of bins, I pass a list of bin boundaries. Okay. Now, if I pass a list of bin boundaries and their corresponding labels, it will basically create these manual bins. Make sense? Okay. So pd.cut can be used to either do equidistant binning or manual binning, right? Okay. Now, when you run pd.cut, as we have seen, you do not get the new variable directly in your data frame. You will get a series which you now have to add to that data frame. You see, if I just run this, I get a panda series, right? If I run this, I get a panda series. If you check the type of this, it will be a panda series. Yeah. But if I want to use this variable in my analysis, this variable should be added to the data frame because that's my source of information, right? So we will talk about later how you can add a panda series to a data frame. When we talk about merging, we'll talk about this, how you can merge one or more data frames or one data frame and a series together. Okay, so we'll come back to this. But for now, is the concept of binning clear, equidistant? Okay, now
In the example, in the
sorry?
example where we have given the bins values,
Mm-hmm.
0, 10,000, 20,000,
Mm-hmm.
these are exclusive or inclusive?
It will always be left exclusive. So 0 will not come in here. Obviously, right, inclusive. So what do you mean by 2, 3 column? Oh, then you will have to write a if-else statement. It cannot be so binning using multiple variables cannot be done using pd.cut. Yeah, it can be done, but not using pd.cut. You will have to manually write those if-else statements. Say for example, if you want to categorize male and female separately, right? For male, you have a categorization. For female, you have a categorization of income. Then you'll have to do it separately. Or what you can do is you can separate out the data frame based on male and female, calculate the bins for them separately, and then add them back. Make sense? You can separate out based on gender, right? Yeah, if gender is equal to male, will give you all the male in a particular data frame. Define these bins for males, define the bins for females, concatenate them, and then append back the data frame. When we covered those concepts, you will get to understand how you can do. Yeah. Okay, now the next concept that we are going to use is known as PD.QCut. PD.QCut is used to basically do equidense binning. Okay, the format of PD.QCut is very similar to PD.cut. Say for example, I want to build deciles for this monthly income. What I will do is I can write PD.QCut within bracket the name of the variable, then the number of bins, and then the labels. Make sense? So what I'm telling Python is create deciles, which means 10 bins, and name each bin with a number between 0 and 9. So first bin will get a number, we get a name 0, second bin gets a name 1, third bins get the name 2, and so on. So instead of alphabetically naming them, I'm naming them by numbers. So if I run this, you will get a panda series of 0 to 10, sorry, 0 to 9. Make sense? Equidense.
Sir, here my question is,
Yes.
like in the result, I can see there is 0 and then corresponding to that there is 8. Then there is 1 and corresponding to that 9. So what does this 8, 9, 6, 9 represent?
Oh,
Is it
it
number of
basically tells 0 is the observation number. So it tells for the first observation, it has gone to bin number 8. Second observation has gone to bin number 9, and so on.
Okay, got it.
No, it will sorting internally. The observation number will not change. The observation number will not change. Internally, it sorts, allocates the bin, and then gives you the bin.
So
But
what is
observation number 1 here is same as observation number 1 in your data frame. The order is not changed. Yes. Sorry. What was the question from online?
so what is the difference between cut and QCut?
Cut will do equidistant binning or manual binning. QCut will do equidense binning.
And sir, the binning is here between the range between 0 to 10, 8.0, 9.0.
No, I have named the bins as 0 to 10. Instead of this, what I can do is I can pass a list of names, right? Say D1, D2, and so on, 10 values, right? Instead of giving alphabetical names, I use numbers to name them. That's
So
it.
D1, D2 will be printed on the place of 8, 9, 6,
So
and
if I
9.
give say D1, D2, and say D3, and I want only 3 bins, then instead of 1, 2, 3, 4, you will see D1, D2, D3. Okay.
Yes, sir. So what is the use of binning in this machine learning?
Binning is done to make your variables more interpretable.
Okay.
Okay.
The labels should always match the number of bins, right?
Sorry.
The label should always be matching the number of bins, otherwise we will get
Obviously, it will give you error.
something.
Okay.
So should we go with,
Sorry.
sir, break?
Not randomly assigning. So what it does is it will calculate the bins for each and every observation and then give them the bin numbers. Say for example, let's go back to Excel, right? Let's say I had age. Sorry. Let's say age, right? Age I have. Okay. This is observation number. Okay, so how many observations do I have? 17. Let's make it 10 to just help me in calculating. Okay, so I have 10 observations. How many observations in a bin? 1. Okay, so in Python internally what it will do is it will first sort it by age. Okay, now then it will create a variable called bin. Now let's say you have named those bins as 0 to 9. So first one gets bin 0, second one 2, 1, 2, 3, 4, 5, 6, 7, 8 and 9. You have given the bins. Then what it will do is it will sort back with respect to observation number. This is what you are seeing when you get output of bin. For each observation, you get the bin number. Make sense? The order of the observation is exactly same as it was in the original data.
So do we use equidence is it that much usable rather than equidistant?
Yes. So in all machine learning algorithm, equidence is used. Equidistant is never used because it skews your distribution. Because there is no guarantee that a particular bracket that you have defined will have observations or not. So from now on, in all the algorithms, whenever we refer to bin, we will actually be referring to equidense binning. And to be specific, we will be referring to only deciling. Right? We will not use equidistant binning. In certain cases, if you have very good domain knowledge, you can use manual binning, right? But if you do not have a domain knowledge, then equidense. Make sense? Okay. Cool. Yes. Oh, NaN is coming because there are missing values. So if you look at this Excel, in the age column, there are a lot of hash NA values.
NA.
So if you look at this column, there is a lot of hash NA here, right? So these are treated as missing values by Python and they will be given a name. Yeah, because you don't know their values, no? So you cannot put them into any bin. बीच बीच पे इसलिए आ रहा है क्योंकि यहाँ पे जैसे फिफ्थ ऑब्जर्वेशन मिसिंग है तो वहां यहाँ पे भी फिफ्थ ऑब्जर्वेशन की जगह पे NaN आएगा ना because order of the observation should remain same. Okay. Cool. Any questions on binning? Great. So I will stop here for now. Let's take a 10 minutes break and we will start around 4. So let's come back to this. Any questions on creating bins or binning? Any questions? No question? Okay. Now, the next concept that we are going to learn about is known as is about renaming a particular column. Say for example,
Anil,
yes,
Kushal this side.
yeah,
Small question. So, like you said, we will be using deciles for the upcoming exercises,
yes,
not percentile. So, can you
not percentile.
explain the reason for that? Like how?
When we do it, na, I don't. I will not have to explain. You will understand why.
Okay, cool. Thank you.
Okay. Now, renaming a column is very important functionality, right? You might want to rename the column names. Let me give you an example. In one of the projects that I had worked on, all the variables were named in Turkish. So, if you look at the Turkish names, it becomes very difficult for any person to interpret, right? So there we had to rename around say 1500, 1600 variables to get them into friendly English terminology, because every time going to Google Translate to find out the meaning becomes very difficult, right? So that's one use case. But apart from that, I'm sure you'll face much more use cases. So renaming a column is done in following ways. So what you do is you say a cast date, I mean the data frame dot rename, and then you write columns equal to and pass a dictionary. Say for example, if I want to rename monthly income as I want to rename monthly income as say monthly underscore income. Then what I will do is I'll pass this dictionary, right? And dictionary in what way? You will create this dictionary in such a way that the old name is the key and new name is the value. Okay. So what is the old name? Old name is monthly income. And what is the new name? New name is monthly underscore income. Okay. Now if you run this, what will happen is if you go to the variable, you will see that the variable has been renamed with the new name.
And this is the permanent change in the.
Yes. So for example, let's say, I mean, I'll give you a generic way to check this, right? So let's say if you don't know whether it has changed or not changed, just do a head on the original data. You see? It's a view, right? So that's why you will see I have written something like this where I have basically assigned it to the same variable. So for example, if I want to change the original data, right? What I can write it, I can simply write something like this. Right? This will originally change the original data. Basically, it's not changing the original data, but it is basically deleting the original data and storing the new values. Make sense? Okay. Now,
And if we have to do it, as you said in your project, you did it for 500
yeah, if you have to do it for 1500 variables,
something column.
you'll have
So
to
if we
create
have to do it for,
key value. Yeah, so you'll have to create multiple keys and multiple values. It's a dictionary, right? One by one.
so everything has to be manual, 1500 columns, or everything we have to write it manually.
Hmm.
Okay.
Um, Not necessarily, right? You have heard of this function called zip.
Yes.
What you see, obviously the new names you will have to come up on your own. Say for example, in Turkish there is a term called something bakiye, right? It basically means new money. So nobody will tell you that, right? So you will have to come up with the names. So new names anyways you will have to come up with. To get the existing names, what you can do is you can write cuts underscore data, and here last day we talked about a function called columns. Yeah. So what this function will give you, it will give you list of existing column names, right? You can put this in a list. Put this in a list to get the list of column names. Similarly, create a list of new column names, right? And then we have studied dictionary comprehension. Use
Yes.
dictionary comprehension to create that dictionary and then use that dictionary in columns.
Okay, got it. Thank you.
So columns can be renamed using column positions as well.
Sorry?
Can we use column positions as well to rename them? Like if on a first
No,
position.
not positions. You will have to give the names. Okay. Now, any other question on rename?
One question is there.
Yes.
Yeah. Sir, once we rename, if we want to regain the original column name of the
No way.
data frame,
No
what
way.
you said?
No way. Once you have renamed, you have
Okay, even
renamed.
same with the drop as well.
Yeah, same with the drop. Once you have dropped it with in place equal to true, it's gone.
Okay.
Yep. Okay. Now, next, the next functionality that we are going to talk about is, see, I am quickly browsing over the functionalities because right now they are very distinct, but when you analyze, you will see you have to use them on and off, right? Depending upon what you are doing. So if I was in your place, I will just remember these terms. And then you will always have the help function, right? Just remember rename, just remember drop, right? Nothing else you have to remember. Okay. Next, sort, right? So if you want to sort a particular data frame by one or more columns, then the method that you will use is known as DataFrame dot sort underscore values, right? Say for example, if I want to sort the data frame cust data by monthly income and I want to sort it in descending order, what I will write is data frame, which is cust underscore data dot sort, and within that by is equal to monthly income. Here you pass on the column name, and then you say ascending is equal to false, which means you want a descending order, right? So if you run this, it will sort the whole data frame by income in descending order. If you want to sort it in ascending order, just write ascending equal to true or don't write anything. Okay, default value is true. Make sense? Now, what if you wanted to sort by multiple variables in multiple ways? Let's say you want to sort by marital status and age, but for marital status you want ascending order, for age you want descending order. Yeah. So then we write data frame dot sort underscore values in by, instead of a single variable you pass on a list. And then in ascending also, instead of a single variable, pass on a list. Remember, the order should be same as the order of the variable. So for example, if marital status is mentioned here first and true here is mentioned here first, it means marital status will be sorted in ascending order. Similarly, age will be sorted in descending order, right? So take care of the order.
So what is the meaning of ascending equals to false here represent?
Ascending equal to false means descending.
Okay.
Yeah, sorry. So what do you mean by sorting by two variables, right? So for example, if I want to sort by gender and age, let's say gender is coded as 0 and 1. 0 means male, 1 means female. So what will happen is it will first sort by gender. So all the zeros come first, all the ones will come at the bottom. Then within 0, it will sort by age. Within 1, it will sort by age.
Sir, instead of writing ascending equals to false, we can use the descending equals to true here.
No, there is only one option.
Only ascending.
I mean, See, I mean, if I say ascending equal to false is as good as saying descending, right?
Why, sir?
So for example, let's say you enter a room and I say that the light is not on. It is as good as meaning light is off, right? There are only two possibilities. Either ordering can happen in ascending order or descending order. If I say ascending equal to false, it means descending.
And what's the meaning of this in place equal to true?
In place equal to true basically means it will change the original data set. If I do not give in place equal to true, it will only produce a view.
Sir, when we are sorting on the two values like marital status and age, and there is a conflict while sorting, either ascending or descending. So, which will take preference, first one or second one?
What do you mean by conflict?
Conflict means if we are ascending marital status on ascending, but age is also at the point that age is not on the descending if we are going to the marital status.
How can that happen?
While we are sorting on the two values, it happens that a second value may not follow the order if we go to the first. So it takes the
So
preference.
yeah, I think there you don't understand what do we mean by sorting by two variables. So when we say sorting by two variables, say for example, I'm sorting by marital status and age,
Correct.
right? So I've given marital status as the first variable.
Yes.
What it will do is marital status is a categorical variable. It can take
Yes.
0 and 1.
Correct.
For example, right? So I'm saying ascending equal to true. So what will happen is all the zeros of marital status will come at the top and all the ones will go at the bottom.
Okay. Correct.
Then the next variable that I am saying is age. What
Yes.
this will do is it will look at within the zero population and it will sort the age within this population in descending order.
Correct. Correct. That's what I
Will
was
sort
asking.
within this as in descending order, right? So the
Yes. Okay.
conflict will never happen.
Okay, so it means it will take the preference of the first one. First,
Yeah.
it will sort on the first variable.
That's
Then
where
it
the
will okay. Then it will sort according to the first variable, the second variable.
Yes.
Okay, thank you.
No? By it will sort the whole data frame. Why would you do that? You understand, right? Say you have the age column, right? And right now your name is corresponding to your age. Correct? Now you are saying I'll sort only age column, but let the other columns remain same. Right? That will screw up the whole data, right? Right? Your name will end up with somebody else's age. Okay. Any question? I mean, you can do that, right? The way to do that is create a data frame with only age, sort it, right? And then merge it back. But again, that will, screw up the whole thing. Yes. Any question on sorting? Okay. Now you see in sorting also there is an in place option. The meaning is exactly the same. If you don't mention, it will not sort the original data frame. If you mention in place equal to true, it will sort the original data frame. Okay. Now, the next functionality that we are going to talk about is another simple one, which is type conversion, right? Let's say I have a variable for gender. It is coded as zeros and ones, right? But gender is not a numeric variable. Gender is not a numeric variable, right? But it is often coded as 0 and 1. What we usually do is, just to avoid confusion, because If you are calculating, say for example, you write a function which takes all numeric variables and calculates their average. Now gender is also coded as a numeric variable, so therefore you will get an average for that as well, right? To avoid such confusions, what often we do is we will convert all the categorical variables which are coded as numbers into characters, so that whenever you shortlist numeric variables, they'll not come. Make sense? So that's where this type conversion is very important, right? So what, how do you convert the type? What you write is data frame dot column name dot as type, and within bracket the variable type that you want. And there is an option called erase on error. It is usually set on false, because even if one or two types don't match, it will forcefully convert it. This is basically forced conversion. Okay, so when I write cust data one dot monthly savings dot as type equal to in 64, monthly savings, if you remember, we calculated it as 15% of income. There's a chance that it has come with decimal places. Now we want to get rid of those decimal places, so we convert this to an integer. No, this will just take the integer part. There is no rounding off. Raise on error is, say for example, oftentimes, say for example, let's say you are converting from character to numeric, right? Now, typically when you are doing that, all of the characters should only have numbers. Yeah, otherwise you should get error. So let's say you are doing it for 1 million records. For 1 or 2 records, there are cases where it has characters in it. What this, if I set it as false, what this will do is this will try two things. First, it will try to forcefully convert it. If it only has characters, it will give you a blank, but it will not raise error. Okay, so that's why you say raise on error is equal to false. Yeah, it will show you error.
And if it is alphanumeric?
Yeah, if it is not able to convert, leave it blank. Yeah. Sorry, what was the question?
And if it is alphanumeric, it will take the numeric part, or what will it do? Or it will mark it
I have never tried that. I just give you as an example. Just try it out and see what happens.
Okay.
Okay. Any questions? A question on this type conversion? Very simple, right? Data frame dot variable name dot as type within bracket variable type. Okay. Again, if you have to remember anything from here, as type. Remember this keyword. Rest you will be able to figure out.
And this one changes the original.
This one changes the original data frame. Yeah. Now, the next functionality that we are going to talk about now is basically resetting the index. So if you remember, I told you that the rows by default takes the names which is same as the row number, but you can choose to change it, right? So for example, if I look at cast data 1 right now, it has the row numbers as the row names. So how do you identify which are the row names? You will see they will be bold on the left hand side, right? You see the row names are row numbers, column names are column names, right? Now let's say I want to change this, right? I want to set this ID variable as my row name, right? So what I need to do is I need to write cast underscore data one dot set underscore index within bracket. I will write ID, right? What this will do is this will generate a view. Remember, this generates a view. It is not changing the original data. It generates a view where if you look at this view, you see the row names have now taken the ID values. Now you see ID is bold. Yeah. Now if you want to actually implement this in your data frame, you write in place equal to true. So if I write in place equal to true, then if I look at cast data 1, you see it has changed. Okay. Not every method, certain methods. Yeah. So you have to check the options. New name as in new variable. Yes, you can. So what you can do is you can pass a list here. Yes, for name of each row. So list should have as many values as the number of rows. I mean, which is possible. Give a list, right? Okay. Now, the next thing that we are going to do is, let's say you have set this ID column as index. Now, after a point of time, you don't like this column. You want to revert back to row numbers. What you do is you write cast underscore data 1, then dot reset underscore index. What this will do is, this is again generating a view where the ID values you see have now become a row, now become a column, and the row numbers are again back. Make sense? Okay. Now, if you want to keep it in place equal to true. Make sense? Two things to remember. Data frame dot set underscore index, within bracket the variable that you want to use as index, or you can pass a list if you want to do that. The list then should have as many values as the number of rows. Then in place equal to true or false. Now, if you want to go back to the row number arrangement, then you write dot reset underscore index. And what will happen? The index that you had will now become a column, and the indexes will now become row number. If it is not unique, it's not unique. I mean, it can still be an index. Yes. How to convert character to date? Okay, we'll come to character to date when we talk about dates. Okay, dates are a bit complicated. We'll come back to it later. Any questions on this? No questions? Yes. Practically, no. But theoretically, yes. You will need reset underscore index, because the reason is often if you are dealing with data of a client, say if you're dealing with bank data, right? You will have a customer IDs there for sure, which will be set as indexes when you download the data or connect to any database, right? Now, when you get it into Python, what I usually do is I reset index and I drop the column. But when you drop the column, make sure that you do not sort the data. Because if you have sorted the data, then you can never merge back with the old data. So understand, right? So let's say, I have this ID column. Now imagine this is a data frame, right? And the ID column is an index. Oh, sorry. Yeah, so this is an ID column, which is an index, right? Imagine this is an index. And then you have variables, right? Say age, balance, etc., etc. What I typically do is I first reset index. So reset index will do what? This will remove this as an index, make this a new variable, and then in place of index, you will have this. Right? Okay. Then what I said is I usually drop this variable. Right? Once you have dropped this variable, what happens is the only way that you can merge back with the original data is by the row number. Right? In the original data, still the first row is what it was in the original data, right? Now let's say I sort it by age. Now what happens? 0 comes in some other place, 1 goes up, and so on, right? Now I can never merge back with the original data because now no longer the rows match, right? So if you drop the index, make sure that you do not sort the data or you do not separate the data. Now when you try to build a model, later on we'll be building the model, you will see in any machine learning model, we will separate the data into two parts. One will be used for building the model, the other will be used to test the model. Now when you separate it, you randomly select the data. Now what happens in random selection? The rows come very random way. Then also you lose the order. Right? So there are certain drawbacks, but I typically delete the index. Yeah. Advantage is I can use ilock or lock to directly refer to row numbers. Otherwise, I'll have to know the exact index. Is it clear? Any other question? Okay. Now, the next one is handling duplicates. Now, again, duplicates are a issue if they are present, right? So you'd ideally want to remove duplicates from your data. Make sense? Okay. So how do you remove duplicates from your data? Duplicate rows or any duplicate in a particular column. Let's say, for example, so duplicates are of two types, right? So one duplicate is that the whole row is exact duplicate. Another duplicate is there is repetition of certain variables. It is partial duplicate, right? Not the whole row is same, right? In both the cases, they are duplicates. Now, how do you treat those duplicates? The first way to treat the duplicates is by detecting them, right? So how do you detect a duplicate? The way you detect a fully duplicate row is by writing DataFrame dot duplicated. So for example, if I want to detect in cast demo how many rows are exact replica of each other. So I will write cast demo dot duplicated, right? This will give me a pandas series with Boolean values. Now, if I want to get the count of the duplicates, I can take a sum, right? This will tell me there are 16 rows which are duplicates. Now, what do I mean by duplicates? Let's say, I'll explain now what this count means, right? Let's say this is an index and say, okay. So in this particular data set, you see these two rows are duplicate. These two rows are duplicate, right? In this particular, if I do a dot duplicated, right, it will be false for the first one, true for the second one, false for the first one, true for the second one, false for the next one, right? So duplicated means if you have multiple rows which are exactly same as each other, first row will be flagged as non-duplicate, the rest of the rows will be flagged as duplicates. So 16 duplicates mean there are 32 rows which are exactly same as each other. At most 32, at most, right? Because the reason being, if I had 3 columns as similar, one of them will be flagged as false and 2 of them will be flagged as true. Yeah. So at max there will be 32 columns which are exact duplicates of each other. Make sense? Okay. Now, if you want to detect duplicates with respect to any particular column, not the whole row, but any particular column, what you can do is you can identify a particular column and call a dot duplicated on this. Now, if I run this, this will give me list of column, list of the data set where the ID has duplicate. Right? If you want to take a count, you can write a sum here. This will tell you how many rows are there where the ID column has been duplicated. Make sense? Okay. Now, once you have identified the duplicates, there are a couple of things that you can do. The first thing that you can do is separate out the duplicates into a different data so that you can take a closer look at them. Right? How do you separate out? Simple. You have created this flag, right? So you create a flag and say cusDemo.duplicated equal to true. All the duplicates will come into this dupes data frame. Dupes is the name of the data frame. Similarly, you write cusDemo.duplicated equal to false. All the unique records will come into this data frame.
So by default, it works on the index column or on the whole data set?
On the whole row. So when I say cusDemo.duplicated, it will only be true if every variable matches with each other, which means the rows will be exact replica of each other. Now, another approach that you might want to take is you say, I don't want to look at the duplicates, I straight away want to drop them, right? So what you can directly say is you can say cusDemo.drop duplicates, right? What this will do is this will drop all the duplicates from your data frame. Make sense? So two things can be done when you have duplicates. First, you separate out the duplicates and look at them in detail later on. Second, you drop them. Now, while dropping, you can actually choose which one will be dropped. So there is an option where you can choose which one to keep. So keep by default is first. So if you have exact replica of rows, the first encounter will be kept, everything else will be dropped. If you choose last, the last encounter will be kept, everything above will be dropped. So for example, if I go back to this, these 3 rows are exact duplicate of each other, right? So if I say keep is equal to first, this row will be kept, these 2 will be dropped. If I say keep equal to last, these 2 rows will be dropped, the last one will be kept. Now, what is the use of this? I'll give you a practical use. Let's say you have a transaction level data working you are working for a retail client and you have a transaction level data. Transaction level data means every time a customer comes, a new line is created, right? So you have customer numbers as IDs. Corresponding to each ID, you have as many rows as many times the customer has shopped in your departmental store, right? Now your customer comes to you and he tells you, I need numbers for the last time this customer has shopped. Or he or she gives you a set of customer names and wants the last data point for each of them. what do? You look at the data, you sort it by time. There will be a time flag, right? You sort it by ID and time flag. So what happens? Each ID, first time flag goes up, the last time flag comes as the last. Then you say keep last. What will happen? It will drop everything with respect to a particular ID and keep the last one. So for every ID, you have the last observation. Did you understand? Yeah. So this is one application where this keep functionality comes into use. Okay, so let's say I have this ID 1111. Huh? Yeah. So I have IDs 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right. These are the IDs, right? And this is, let's say, their purchase value. And this is, let's say, date, right? Let's say customer 1 purchased some random amount. And let's give some random date, right? 01 Jan 2019, 02 Jan 2019, 03 Jan 2019, 04 Jan 2019. Okay, so this is a transaction level data, right? For you see, customer 1 purchased for certain amount on 1st January. Customer 2 purchased for certain amount on 1st January, right? Then again, customer 1 came back on 2nd January, right? So now the client comes to you and he or she will ask you, give me the last purchase amount for each customer. So what you will do is you will first sort this data. How do you sort it? Sort values,
On
right?
ID.
Yeah.
Sort
So
value.
you sorted using sort values using first customer ID. Then within customer ID, you sorted by date, oldest to newest, right? And say okay, right? So once you have done that, you see each customers have now formed clusters. Now what we will need to do is we'll need to find duplicates with respect to the ID, right? So these two will become duplicate, these two will be duplicate, and so on, right? Then you will drop duplicates by keeping the last one. So what will happen? These two will be deleted. These two will be deleted. These two will be deleted. And these two will be deleted. So at the end, you are left with the last purchase that each customer had made. Make sense? Okay. Now, any questions? Okay. Now, yes. What do? Okay. So if you want to know what keep equal to false means, it will drop all observations wherever it has found any duplicate. Sub jayega.
So including the original one.
Sorry?
Including the original one.
Yeah, including the original one. If you say keep equal to false, this basically means you don't have to keep anything. Okay.
What if we want to delete the duplicate columns?
Duplicate columns. So you mean same column has been repeated multiple times?
Yes.
Drop.
Okay.
Drop. Yeah. See, most of the functions that we are going to study, all of them operate across columns. They cannot operate across rows. Sorry, across, I mean, you understand, right? Across rows means it will take multiple rows. It can traverse upwards and downwards. There are very few functions which can traverse left and right. The reason being, in any kind of analysis, you typically concentrate on one variable at a time. You will not, say for example, if you have age, height and weight, whenever you talk about statistical measures, you will never combine age, height and weight and calculate their sum. Doesn't make sense, right? Neither will calculate age, height and weight average. What we will calculate is average, sum, etc. for each column. So all of these drop, duplicates and most of the functions that we are going to study operate on a particular column at a time. So if you have multiple columns, you cannot use drop duplicates to drop it. What you will have to do is drop them using the drop method.
We can work on by transposing them as well. Then we can transpose it.
A transpose, right? You can transpose them, but then the problem is you will end up with a very wide data, which will occupy a huge amount of space. Yes, you were saying what? Yeah.
So drop duplicates will delete only the rows that are exactly same.
Yes.
What if we have duplicate values in cells?
What do you mean by cells? In a particular variable?
Yes, in a
Yes.
particular.
So we talked about it, right? So you can give the name of the variable and then also ask for dot duplicate.
Okay.
Now, what if you want to drop basis duplicate on a single variable? Right? Even if there is duplicates in ID only, you want to drop them. No, not using ilog and log. So I will give you this as an exercise. Figure out. So for example, look at this, right? This command drops a line only if the whole line is exact duplicate, right? How can you change this to drop a particular row even if one variable is a duplicate? Figure out. Yeah. Okay. The next concept that we are going to talk about is how to handle missing values. Now, in analysis of data, what do we mean by missing value? Missing value is basically where there is no value. It does not mean blank. If two variables are duplicates, you need to pass a list instead of a single variable.
Okay, just before this, when we are checking duplicates, we are ignoring the missing values, right? They are not counted as duplicates.
No. Missing values are not considered in any of these, neither in binning, not in duplicates.
Okay, okay.
Okay, so what do we mean by missing value? Missing value is basically no value. Does not mean a blank, because blank is still a value, right? Or does not mean zero. It just means no value. There was no value present. So for example, if I'm collecting data on all of your ages, right? And today one guy is not present. So corresponding to his name, there will be no value. It means there is a missing value. Now, missing value in analysis are categorized into two types. One is known as systemic missing. Second one is known as missing at random, right? So first one is known as systemic missing. Second one is known as missing at random. Now let's understand what each of these mean. So when I say systemic missing, it basically means that there is a reason why the data is missing, right? Let me give you an example, right? So often when we work in banking data, there is a variable which says background verification or KYC updated, right? It is either yes or no, right? Or it can take 1, 2, 3 depending upon the codes, right? Or often it tells you how many months have passed since the KYC was last updated. All of you understand KYC? You have to go to the bank and refresh your documents, right? So there is a field which tells you how many months has passed since the last KYC was updated. Now, when we were analyzing it for the first time, this actually happened for a client, we saw that there were missing values in certain cases. Now, typically, when you see missing value, you typically assume that this is missing at random. Due to some random reason, somebody forgot to update, right? Now, in that case, there are two options. Either you replace those missing value by average, or you drop those missing values. You remove the whole row, right? What we did was we removed the whole row because the number of missing values was less. So we had a huge amount of data. We decided to remove them. Now, later on, what we realized were we had dropped all the high net worth customers. Because for high net worth customers, they don't have to do KYC. So the field for them was blank due to a reason. Make sense? Right? So whenever there is a reason behind a missing value, it is known as systemic missing. Right? When you have systemic missing, let's see how you can treat them. When you have systemic missing, the best way to treat them is by considering missing as a new category. Right? So for example, when we were talking about number of months since last KYC was updated, we anyways had to bin them, right? What we should have done is treat the missing values as a separate bucket, right? Then they become a part of your analysis, right? Let's say the usual thing that people do is they will use a dummy code like -9999 and so on. I mean, I don't know why this is used. In most of the cases, people use -49s for some reason, right? They use that, right? So you will typically see a lot of -49s if you look at any analytics data. People usually replace it by -49. There is no reason for it. It's like a universal way of doing it. So the way to treat this is consider missing as a new category, right? Makes sense? Now, missing at random. Missing at random means it has been missed due to some unknown reason. There is no apparent reason for it, right? Maybe somebody forgot to log in, maybe it was a database error, whatever, right? If you have missing at random, the way you can treat them are twice. For the first way or the usual way that people treat them is drop the rows, right? Now dropping the rows will only work if the number of missing values are very low as compared to total number of observations. What is the definition of very low? The usual definition is if it is less than 1%. If the number of rows having missing value is less than 1%, then you can afford to drop it. But there is a caveat to it, right? Let's say if you are dealing with a data set which has 10 million data points. What is 1% of 10 million? 1000, right? You cannot drop 1000 rows, period, no matter what is the data size, right? You cannot drop 1000 rows because 1000 is a significant number. You might be losing a lot of features by dropping it, right? So the usual threshold is around 1%, but the maximum number of rows that you will typically drop is probably 100, right? Nothing beyond that. Okay. Now, first is drop the rows. The second is missing value replacement. So what you do is, since it is missing at random, you will take such a value which is very typical, right? What do you mean by typical? Typical basically means either average or something similar to average, right? Average is a typical value, right? Average is something which you would see in most of the data points, right? So for example, if I am looking at your data of age, if one guy is not here, I'll typically assume that his age is exactly equal to the average of all of you, right? So the missing value replacement, you will typically replace the missing values by average, right? Or some user input. I mean, if says the business tells you whenever you say missing, replace it by 500, right? Very rare, but happens, right? In that case, you will use that user input. Make sense? Okay. Now, there is a problem in using average as missing value treatment. We'll come back to this when we talk about outliers, right? There is a problem here, and we'll come back to this, right? For now, assume that average and user input are the two options. Make sense? Now, during the period of this course, whenever you see missing value, we will by default assume them as missing at random. Because there is nobody here to justify the business. So we'll assume that it is missing at random. And whenever we assume it as missing at random, we will do missing value treatment. Reason being, our Excel files that we will deal with do not have very large number of rows. If you drop rows, you will lose features. So the only missing value treatment that you will do during this course of time is either a user input or an average. Clear? Okay. Now, let's talk about how we can do all of this in Python. See, Gaurav, I just told you if the number percentage of missing value is less than 1%, you can choose to drop. If it is anywhere more than 1%, you will have to replace. Okay, now, dealing with missing values have two parts to it. First is you detect whether it's missing or not. Second, you do something about it, right? Just like duplicates, right? You detect whether it's duplicate or not and then treat it, right? How do you detect whether a particular value is duplicate or not? You use is null, right? Say for example, I want to detect whether monthly income data has any missing value or not, right? What I do is I can store it in a different variable, or I can directly write on this. I can write cust data, then monthly income, and then I write is null. So for example, so remember monthly income had a lot of hash in it. So it has missing values, right? So if you write dot is null, you'll get a series of Boolean, right? Now this series of Boolean can be used in multiple ways. What are the ways? I can create a sum out of it. What will this sum tell me? How many number of missing values? I can look at the rows. What I can do is I can write cust underscore data, and then within bracket I put this Boolean series. This will give me all the rows where monthly income is missing. So if you look at this data, you see all monthly incomes are nan. Nan in Python is missing. Make sense? Python. What do you mean by this sheet? This sheet is Python data frame. Oh no, Python format, Python data frame format of missing value is nan. Okay, so you can use is null to figure out which rows are missing, right? You can take a sum of it, display the rows and whatever, right? Then the opposite of is null is not null, right? So if I want to know how many rows are not null, what I can do is I can get a sum of this, right? What I can write is I can write cust data monthly income dot not null. And this will tell me how many non-missing rows, how many rows are there where monthly income is non-missing. Make sense? Okay, so two things to remember: is null, not null. Now, once you have detected the missing value, like I said, there are two ways to treat it. Either you drop it or you replace it. We'll not drop it, so we'll talk about replacement, right? Dropping, you already know how to drop, right? You have got the Boolean series, then you can drop the rows. Okay. Or what you can do is you can only keep rows where is null is true. That will also work. It will create a new. So you can create a, you understand, right? You can write monthly income dot is null is equal to true. That will create a new data frame with all the null. Is null equal to false, creates all the data frame with non-null. Now, if you want to replace the missing values, you will have to use fill any, right? So what you have to write is monthly income dot fill any. Now within fill any, you can choose to give a user input or you can choose to give a statistical input. Statistical input meaning either median or average or anything else. Typically, we will choose average, yes. Column, yes. What do you mean by categorically median? Not necessarily, right? Customer one has only one value, let's say. No, that is not necessarily always the data structure, right? Let's say I take all of your age, whole column. So you see what I am writing, I'm writing dot the column name dot mean, right? So it means the mean of that column. So for example, if I want to replace all the missing values of monthly income, so what I do is I write cust data, then monthly income, then I write fill in it, and then if I whatever value I want to replace it with, right? So if you want to replace it with by mean, what you will write is dot mean. This will create one second. This will create this row with all the missing value filled in, right? Now, if you want to replace the old column with the new one, what you just need to do is you need to write this. What this will do is this will replace the old value with the new column. Hey, queries? Oh, S12 is just the name that I've given to this. So if you go up, I have created this, right? S12 is equal to cust data monthly income. So instead of writing cust data with the monthly income, I have renamed it. You also had the same question. Okay, so this is all about missing value treatment. Any question? In place is not required. No. So when you use fill NA, it will always create a new pandas with the filled values, right? Now, if you want to use these new values in your data frame, you have to write something like this. It will not change the original data frame. Yeah. If it is a categorical variable with missing value, the usual thing that we do is we will treat missing value as a new category. Or what you can do is you can calculate mode. You understand mode? Mode is the category which is most frequent and use that to replace. Which one? Yes, this is the only thing that we'll use. And what else is the option? There are no options, right? Same as mean, right? Mean is average. Mean is average, right? All of you know that. आप average लेते हो तो average ले लो. Yeah. See, this is the simple way to do it, right? The complicated way of doing it is, and you will learn this when we go into machine learning. Often, what people do is people understand the pattern behind missing, right? You build an algorithm which will predict what would have been the value basis the other variables that are present. Say, for example, I note your age, height, weight, skin color, hair color, right? Now, let's say age is missing for one particular person, right? What the algorithm will do is it will take height, weight, hair color, and skin color and try to guess what would have been his age. That is a complicated thing to do. Simple thing is replaced by mean, works every time. Okay. Yes. So, any other question?
So much dirty way. I mean, it's not the arranged way that we are working on customer demo or customer because all data is available and all data is correct. But in industry, you will not get that kind of data in a structured way. You get the data in a structured way. So sometimes your age is wrong and something other is wrong, mobile number is wrong. What do you want to do that? I mean, practically, I'm asking you.
Yeah. Depends, right? So data cleansing is something that cannot be taught. It varies from case to case. For example, the case that I told, right? Every variable was in Turkish. That is one form of data cleaning. You have to make everything make sense. Sometimes what happens is, especially in transaction level data, you will see that the values often get concatenated with date. So, I mean, it has to be dealt case by case basis. So when you do the capstone projects, you will get a feel of the practical scenario and you will figure out how to clean up the data, right? Who are these people? Okay. Okay. Yeah, correct. No, this is simple form of data cleaning. This will not take 70% of your time, right? So fill in is just 1 second. 70% time is not used here. 70% of the time is used basically to clean the data to actually understand what is a missing value. So often even missing values are so well hidden and coded, you need to decode to get to understand what is missing value. So often in data frames, what they'll do is wherever they're missing, they'll put in junk values. So for that, you will have to understand which is a junk value and then remove that so that you can get which is a missing value, right? All of that will not cover right now, right? Because right now we were starting with just the simple problems. And once we go to that complex level, we'll talk about it. This is not data cleaning, which takes 70% of the time. This is not that. Yeah, missing value is just a small part. It takes very less time. Yes, anything else? Cleaning up the data? Yes. Yes. We'll learn the algorithms, but it is up to you whether you want to use it. Right? We'll learn the algorithms. Okay. Anything else? No? Okay. So I will stop here and yeah, so if you want to replace variable missing value from all the columns, you will have to write a function. There is no direct way of doing it. Okay. Now for tomorrow, we will work on this same thing. Okay, that's fine. Cool. Now one question to you guys, right? And this might be a bit early to understand. So what I'm doing with the other batch that I'm going over, right? So I have started with a new approach. So what is this approach? After every significant chunk, we'll have one class where you guys will come here and practice, right? That might not make sense to all of you, right? If it makes sense to you guys have your WhatsApp, right? Let me know in coming next 2 to 3 weeks, right? Then when we cover a significant chunk, we'll dedicate one class for practice. Okay, but let me know in next 2-3 weeks. I mean, it's fine for you. Just get the majority opinion. Right?